Welcome back to another Tony Montana video. I want to remind everyone that all the content in the channel is intended for informative, educational, and historical purposes. Remember to press the like button and to subscribe to the Tony Montana APBT channel. The following is part 2 of the article, Pitbull, Physical Conditioning, written by Tom Garner, a renowned breeder of American Pitbull Terriers, on a global level. Types of fitness. It stands to reason that just as there are varying kinds of work characteristics for our muscles, there are also varying kinds of fitness to do that work. Fitness experts generally talk about 3 primary aspects of fitness. 1. Cardiovascular, ability of the heart, lungs, blood and blood vessels to transport oxygen, fuels, repair materials, and waste to their respective destinations in the body. 2. Muscular endurance, ability of muscles to repeatedly/continuously do a particular kind of work without failure from fatigue. 3. Muscular strength, the ability to generate extreme power to accomplish difficult work over a short period of time. The status of each of these 3 components of fitness is determined by amount of type of work. Work/rest schedules. Nutrition and hormones. The relationship between these types of fitness can best be defined as complex. Under some circumstances they all improve/increase together. Under other circumstances, an increase in one type of fitness may result in a decrease in another type. We will explore these general tendencies at this point. When a person or dog goes from a non-exercise lifestyle to an active exercise lifestyle, gains are initially made in all fitness areas. Cardio fitness, muscular endurance and muscular strength all improve after a period of general, across-the-board increase in fitness. A point is reached in which continued gains in muscular strength. In fact, muscular strength may well decline as the cardio and muscular endurance increase. Cardiovascular fitness is defined in relative terms: the abilities of the heart, lungs, blood vessels and blood to transport oxygen, fuels, repair materials and waste must meet the requirements of the muscle mass they serve. A dog's cardiovascular system may be quite adequate for his body if he is engaged in running at modest pace. If he gains 5 pounds of additional muscle and pulls a heavy sled as he runs, his cardiovascular system is required to perform at much higher level and will likely fail to keep up. Muscles that are trained for strength more than endurance are altered to burn fuels, create waste, lactic acid, and use oxygen at a much faster pace. These substances must be supplied/removed at a much faster rate. Therefore, extensive strength training can render a formerly adequate cardiovascular system inadequate. It is a real dilemma for an athlete or a trainer to know precisely how to balance strength, endurance, and cardio training so that the most effective profile is provided for a particular athletic pursuit. If you can train by doing the activity in which you will compete, the problem is essentially solved. Remember the second law from above? The body adapts its response to a given type and volume of work. By becoming more fit to do that type and amount of work, the body also dials in the correct balance of the various types of fitness under these conditions. The real problem occurs when it is not practical to train in the precise activity in which you will compete. The boar hunt we often refer to is one such example. Battling with a big boar is such an extreme activity that takes such toll on its participants that a dog would not likely survive regular tussles of this magnitude long enough to become fit. Solution is to be smart enough to figure out how much of the various types of fitness are required for the contest, then devise a program that will work the right muscles, with the right balance of endurance and strength training and sufficient cardio capacity to keep up with the muscles' needs. If we effectively devise a program that simulates the fitness fingerprint of the actual hunt, we have a much better probability of being the victor in our boar hunt. One point that soon becomes clear to trainers and athletes is that you can't have too much cardiovascular capacity. So why not just do daily marathons? Because doing too much cardio work actually results in diminished muscle mass. The body actually works to rectify a mismatch between cardio capacity and cardio needs from both ends. It increases cardio capability and reduces cardio need by reducing muscle mass. The process through which this is accomplished is primarily hormonal. We will explore this mechanism in depth, along with ways to circumvent it, a little further along. Hormones, anabolic versus catabolic. Many aspects of human and canine bodies are controlled by hormones. Secreted by various glands, hormones fit like keys into receptor sites of specific kinds of cells and cause powerful changes to take place within their target cells. Growth rate, muscularity, body temperature, distribution of nutrients, red blood cell production, and our fight or flight response to perceived emergencies are all controlled by hormones. Thyroid hormone, human growth hormone, testosterone, insulin, erythropoietin, adrenaline, and cortisol are all powerful hormones that powerfully affect the composition and function of our bodies on a daily basis. All of the hormones listed above have great relevance to the development and shaping of an athlete, but there are two groups that work against each other in a sort of ongoing, uneasy compromise to define the makeup and metabolism of the body. Metabolism is the collection of biochemical processes in an organism, through which food is assimilated into body tissue, through which is food utilized for energy, and through which body tissue is broken down into simpler compounds and energy. The processes that result in buildup of body tissue are called anabolic. The hormones that work to carry out anabolic processes are insulin, testosterone, and human growth hormone. The processes that are concerned with turning body tissue into energy are called catabolic. The ione-crusading hormone for this side is cortisol. If you are enjoying this audio/video, show your appreciation by pressing the like button, subscribing to the Tony Montana channel, and sharing the video. Now, back to the article. Cortisol. Imagine a body that had only anabolic hormones. It would grow more and more muscle and fat until it finally become too big for the internal organs to service. It would lose athleticism due to excessive weight, and cardiovascular endurance for long-term work would be pathetic. By default, this tells us a little bit about the role of cortisol. One of the functions of this hormone is to help strike a compromise with the army of anabolic hormones to ensure that the size and composition of the body is within a range that the heart, lungs, and other major organs can service. Moderate levels of cortisol serve many positive functions, including gluconeogenesis, turning protein into energy, and control of inflammation in joints. It is interesting to note that cortisone, dexamethasone, is a synthetic version of cortisol, and these two substances have very similar effects on canine or human bodies. In fact, we can induce the effects of elevated cortisol by injecting cortisone/dexamethasone. This is a point we will talk more about later. When the body has a fight or flight emergency, it depends on a heavy release of cortisol to turn body tissue into energy to fuel an extremely taxing athletic response. If a wild animal is confronted by a fast-moving forest fire and has a choice of either run for 24 hours or perish, it is energy provided by cortisol acting upon body tissue that fuels this marathon. The animal will lose significant weight and his body will be harmed, but he will survive. Through prolonged secretion of heavy amounts of cortisol, the body can be damaged and the initial stages of many serious diseases can be set into motion by excess amounts of this hormone. After all, cortisol specializes in breaking down and metabolizing body tissue. Cortisol is thought to play a role in altering DNA, which can result in inaccurate cell replication. This is the basic mechanism through which cancer begins. The IIU1ER lining of our blood vessels are also damaged by excess cortisol, allowing deposits to begin to bind inside our plumbing. As a result, our vessels become clogged. When the bloods can no longer flow, we die. Even schizophrenia is believed to have a cortisol-based component. This psychological disorder is typically preceded by long periods of stress and elevated cortisol. Cortisol certainly appears to be something we might like to be able to control. But what triggers the release of this hormone? This is one of the few places in which the answer is at least partly different for people and dogs. The short answer for both is anything that causes stress. Physiological stress in both humans and canines elevates the cortisol response. Many events fall into the category of psychological stress. Included on this list are disease, prolonged exercises, inadequate sleep, burning more calories than are ingested, and cold temperatures. The most extreme condition that represents a psychologically induced cortisol response in dogs would be the fight or flight response to imminent danger. It would be an interesting bit of research to determine if there are unique parameters to this response within the APBT. Other psychological stressors for dogs include inadequate human/social contact and separation from normal companionship. Ever see a dog that won't eat when separated from his master? It would be interesting to investigate the dog's cortisol levels during this sort of mental state. For us humans, the presence of elevated cortisol in our bodies causes us to have a feeling we know as anxiety. The way we know we are stressed is that we feel anxious, i.e., the feeling of elevated cortisol in our body is anxiety. I provide this information redundantly because it is useful to understand that we effectively have a built-in cortisol meter. If you feel anxious, you have extra cortisol floating around. Anything that causes us to worry, or imagine an undesirable outcome to our circumstances, results in this cortisol release. This is a flaw in our biomechanical nature. We need cortisol to turn body tissue into energy for real emergencies, not for imagined or hypothetical emergencies. Ever notice how people we describe as warriors are typically thin and look undernourished? How about the effect of losing a loved one on other family members? The weight loss and wasting we commonly see demonstrate the effects of worry-induced prolonged elevation of cortisol. So now we know why it is so important, when we are training and trying to build muscle tissue, to eat right, stay warm, mix the right amount of recovery time with the work. Avoid colds, don't involve ourselves in circumstances that will cause us to worry, and very importantly, get enough of sleep. Sleep is a special condition that warrants extra attention. Every 45 minutes we go sequentially through 4 discrete stages of sleep. The third stage is called REM sleep. During this stage, short-term electrical memory is transformed into long-term chemic 1L memory. Dreaming is a sort of byproduct of this process. Stage 4 sleep is when most of our anabolic hormones are secreted. Each 45 minutes a new sleep cycle is repeated. Each successive cycle has a longer stage 4 component. The final 45-minute cycle of a full night's sleep is almost exclusively stage 4 sleep. Consequently, most of our anabolic hormones come from this final 45-minute segment of a full night's sleep. I hope you enjoyed this informative article and that you showed your appreciation for the time it takes to put these things together for the sake of the APBT community around the world. Tony Montana works hard in providing information not found anywhere else on the web or YouTube. Tony Montana wishes you a good day, and please, say hello to my little friend.